Hello everyone, in this video we are going to learn the bonding and magnetic behavior of different coordination complexes on the basis of your valence bond theory. So what is a valence bond theory? Valence bond theory means whenever a metal forms a complex with a ligand or time, we say that they form complexes, okay, and their shape, how the complexes will look like, is determined by your valence bond theory. So it is said that we know that there is how many orbitals? We have P, D and F. These are nutels in which electrons are placed in an orbit, or you can say electrons are placed in these kind of shells in their definite order. Like if we see valency, or if we know the atomic configuration, okay, of nickel. What is nickel? Nickel, its atomic number is your 28. So S2, if we write 2s2, 2p6, say 2p6, then 3s2 and 3d. So it is 6, 7, 8, 9, 10, 11, 12, 18, 4s. We can say 4s2 because we fill the s subshell first, then we go for filling the d subshell. Okay, so 18, 19, 20, 18, 19, 20, and this is your 8. How many electrons are there in d subshell? That is 8 electrons in the d subshell. So argon 18, 3d 8 and 4s2. So these complexes, no, when we go to these, is that they have low electrons which is there in your 3d orbitals, okay, and these electron, okay, which is you are unpaired electrons, they form coordinate with these ligands, okay. So ligands, so you can say for a valence bond theory, it should have an empty orbital, okay. So there is an empty orbital. See, in this case, if we draw the orbital diagram, okay, so we know the last is your 4s2, so 2 here out here and 8 out here. So 1, 2, 3, 4, 5, 6, 7, 8. So 2, there is 2 unpaired electrons. So there should be an unpaired electron, and the ligand which is there should have lone pair of electrons. So these lone pair can come and form bonding with these these 3D metal atom to form complexes. Okay, so this is called actually a valence bond theory. So the valence bond theory can explain you the shape. Okay, it can explain the shape, but it cannot, and somewhat the magnetic behavior also, but it cannot explain the electronic spectra. Most transition complexes are colored. Okay, so they cannot explain the limitations. What is the limitation? Is complexes are colored, which cannot be explained by this metal. Complexes are colored, which cannot be explained by this theory. So we again go for molecular orbital theory. We will discuss in this in the other class. And the second thing, it's the paramagnetic behavior, or you can say magnetic property vary with temperature. Magnetic property vary with temperature. This one also it could not explain. Vary with temperature. So these two things it could not be explained by this theory. But still, you can say it can explain you the shape and somewhat magnetic behavior. Okay. By valence bond theory, let me first find what will be the shape and magnetic behavior of nickel CuO 4. Okay, how will you find that? First, nickel comes in 28. Nickel is 28. Atomic number is 28. So your atomic configuration will be, it should be 4s2 and your 3d 8. Okay, so nickel in your ground state, it is like this. We are just drawing the subshell of the last orbit. Okay, we are doing the subshell 4s and 4p. Okay, so how many? Here it is 2, 1, 2, 3, 4, 5, 6, 7 and 8. Okay, you have to see this ligand. So what ligand it is attached to. If it is forming these kind of complexes, what is the most important factor is that this have empty orbital with suitable energy available for bonding, and the ligand must have the lone pair of electrons. So those ligand which will have a good number of lone pair are better for bonding, and are also called your strong field ligand. So this CO, carbon monoxide, is a strong field ligand. So what will happen? It will pair up all the electrons. So how many electrons are total out there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so it will pair up first. Okay, these electrons will come here and pair up. Okay, It is done. So now the for available for bonding, which orbitals are there? This is S and P. So how carbon monoxide molecule are there? It is 4 given to you. So this is going to form, these are going to give the lone pairs in your S and P orbital. So it is forming your sp3 hybridization. Okay, so which hybridization it is forming? It is forming your sp3 hybridization, and the structure of sp3 is tetrahedral. So the shape will be like this: nickel, here it is cobalt, tetrahedral shape. We know this. This is your tetrahedral shape. Okay, so this is the ligand. Okay, so it is giving lone pair of electrons to nickel and forming the bonds, coordination compounds. Okay, so this way we will show the diagram. So this is your, here it is paramagnetic or diamagnetic. You can say it is diamagnetic because there is no more electrons left to show any magnetic behavior.